All right, this video is going to talk all about how to graph a system of inequalities. But in order to understand graphing a system of inequalities, first let's review very quickly, how do you graph a single and a linear inequality here? So on the screen, we've got 2x minus y is greater than or equal to -3. And one of the simplest ways to graph a linear equation or inequality is to first put ourselves into y equals mx plus b form. So let's go ahead and solve for y up here. I'm going to subtract 2x from both sides, basically leaving me with negative y is still greater than or equal to a -2 minus 3, or -2x minus 3. Then I'm going to go ahead and divide by -1. Now don't forget, this is an inequality. So that means that if we divide by -1 on both sides, remember we know the rule, we're going to flip that sign, and -2 over -1 becomes a positive 2x. -3 over -1 becomes a positive 3. Now, sort of ignoring the inequality, I'm going to go ahead and start graphing. I'm going to plot a point up at 3 for my y-intercept. And then I'm going to use 2 as my slope, right? Or 2 over 1. So I'm going to go up 2 right 1, down 2 left 1, and kind of continue that so I cover the entire graph here. Because I have an or equal to symbol, remember we're going to graph a solid line. If it was not or equal to, we would have graphed a dashed line. But again, we're going to be solid there. And then the easiest way to figure out where to shade is to just check a point. So if I took the point 0, 0, and I plugged it into my inequality, if y were 0 and x were 0, right? Well, that gives me 0 is less than or equal to 0 plus 3 is 3. And because 0 is less than 3 is a true statement, I'm going to go ahead and graph towards 0, 0. Right? I'm going to shade that entire side of the graph. Again, that's just the basics of graphing an inequality. The difference with a system of inequalities is that we're going to have multiple lines. So notice over here on the graph, we've got 2 dashed lines, so they must have been not or equal to. One solid line in orange there on the bottom, that's an or equal to. And notice we are graphing above or greater than the orange line. We're below the red line or less than that, and below the blue line, so we're less than that. Because we only want to satisfy what works for all of the inequalities, notice we're only shaded in between those lines, right? Again, even though all of this space above the orange line would technically be greater than that orange line, we also had to satisfy being less than the blue and less than the red. So only the green area, right? Not all these other spaces that would have sort of satisfied one but not all parts. Only the green area is our shaded region of answers. So again, a system has 2 or more inequalities. Remember that we can have dashed or solid lines around the edges, but again, you only want to shade where all of the graphs overlap, where all of the graphs exist. So let's take a look at an example of that. If we wanted to graph the line x is greater than or equal to 0, remember x equals makes for a vertical line. So x equals, again, is the y-axis. So I would draw a line, right? I would draw this blue line here right on top of the the y-axis. And x is greater than or equal to 0. So technically, everything greater than that line, everywhere that x is greater than that line, is all over the right side of this graph. But, again, I haven't satisfied all of the other inequalities yet, so I'm not going to quite shade that. I'm going to give myself a note, though. Up at the top, I'm going to sort of just make a couple of marks to remind myself I'm on the right side of that blue line. Then, let's go ahead and do this next one. Y is also greater than or equal to 0. Well, y equals 0, remember, is the x-axis. Every point on the x-axis has a y value of exactly 0. And if y is greater than or equal to 0, we're going to be above the red line, right? So I would be up here. But again, I also wanted to be to the right side, right, of that blue line. We would have been over here. Well, the only place they overlap is up there in quadrant 1, right, up here in this area. And because I don't want the red over here and I don't want the blue over here, I wouldn't want to overshade like that. Again, I'm just going to make a small note that I want to be above the red line. So far I'm up there in quadrant 1. I'm just going to make that note so I don't forget. But we still have a couple of lines to go. So if y is less than or equal to 2, well, y equals 2 again, is a horizontal line. And again, if I want to be right of the blue, above the red, but now y is less than or equal to 2, I'm going to be below the orange. So right now, again, I would be in this small area right here. But again, I still have another line to go, so I'm going to hold off on that. I'm just going to make a little bit of a mark again over there on the right side, just to remind myself again, I'm right of the blue, below the orange, above the red. I'm kind of in this area so far. Right? And then finally, let's get that last one on here. We'll do that one in purple. Again, we've got a y equals mx plus b equation. So I can start up at 5. 2, 3, 4 is 5 right here. And I can also count down 1, right 2, right? A slope of negative 1/2. Down 1, right 2. Down 1, right 2. And crossing through that area. And notice again, another equal sign, or equal to, so I'm going to go ahead and draw a solid line, right, through that area. And because y is less than, right, now I could test the point if I want to, so testing something like 0, 0 would work. And is 0 less than or equal to 0 plus 5? Well, is 0 less than 5? Yes, it is. So I'm going to shade below the purple line. But remember, you can also sort of check that by looking at that inequality symbol. Y is less than. So we're going to shade below, right, that purple line. So I want to be below the purple, above the red, below the orange, and right of the blue. If you kind of keep track of those parts, again, right of the blue, below the orange, above the red, but again, below the purple, we're only going to be in that small area here. There's still an infinite number of answers, because if we consider decimals and fractions, there's an infinite number of points in there. But again, this is a very bounded, as we call it, or sort of constrained region, a bounded region. It's surrounded on all sides. But I only want to shade, again, the part that satisfies all inequalities. Right of the blue, greater than x is greater than 0. Above the red, y is greater than 0. Below the orange, y is less than or equal to 2. And we satisfy the purple line, right? We're below that purple line. So we've got that area there. Again, we also want to add just some labeling. So let's just say that that was 5 there, and I can label 5 here. So we counted by ones. Always a good idea to label. Probably want to do that before you start graphing. But the most important part, make sure you're shaded between those lines. Let's try another one real quick. If you want to, feel free to pause the video now. See if you can't graph this out, and then see if my graph matches yours when you're done. All right, let's go ahead and we'll try this out. Again, the first thing I'm going to do is solve for y. I'm going to subtract 3x, right, over from this side over to that side. So we basically become y is greater than negative 3x plus 9. I'm going to go up to 9 and a slope of negative 3, right? Going down 3, right 1, down 3, right 1 the whole time. Now notice no equal sign on this one. So again, we want to make a dashed line. And if it helps, you can even write dashed at the end of your line, right? Just so that you know once it gets a little messy in the middle, right? We might lose some labels as well, so I'm going to go ahead and label this 10 there, and maybe positive 1 here. And if our labels get covered up, I might just have to put some more labels on there. Then I'm going to go ahead and go back with red here, and I'm going to do the next one. Negative 2y, again, subtracting x over to the other side. But now I'm going to divide by negative 2. So y becomes less than or equal. Don't forget to flip that sign. Now, negative 1x divided by negative 2 is a positive 1/2 x. And positive 3 divided by negative 2 would be a negative 3/2. Now, the y-intercept is not bad there. That's a negative 3/2 or a negative 1.5. But that's going to make it a little trickier to count out. So what I might do is actually just plug in a point. I might plug in something like x is 1, because 1/2 times 1 would just be a half. Sorry, I'll get that screen out of there. 1/2 times 1 would be 1/2. And 1/2 minus 3/2, right? 1/2 minus 3/2 is really negative 1, right? Basically adding a positive 1 or 0.5 to a negative 1.5, right? If I plug in 1 here, 0.5 plus negative 1.5 is just negative 1. And notice at 1, negative 1, we would have also been up a half, right, from our original point, right 1. But now that I'm at a nice coordinate, I can go up 1, right 2, up 1, right 2. I can use that slope of 1/2, right, to make a nice long line here. Notice this one is or equal to, so our solid red line is going to go through all of those points, hopefully as straight as you can draw. And if we double check, again, I would want to check some points here to figure out some shading. Well, for this line, if I check 0, 0, the nice part is we're in standard form. So 0 minus 0 greater than 3, well, is 0 greater than or equal to 3? Well, I would say false on that one, right? So I'm going to shade below the red line. So I'm going to be over kind of below there somewhere, right? Whether that be in this lower area or in this right area, I want to be somewhere below the red. But at the same time, again, I'm going to do the same thing up top here. If I check 0, 0, right, 0 times 3 plus 0 would be a 0 greater than 9. And again, because that's also false, well, from the purple line, if 0, 0 is false, I'm going to shade sort of above or to the right. So where we really want to be is below the red to the right of the purple. So we're going to be down here in the lower right. That's my shaded region. That's my good region of answers. I hope that helps you graphing systems of inequalities. Feel free to watch the second video. That video is going to show you how to go backwards. If they give you a system graphed out, how would you write the equations? Just a couple of reminders from things we've done earlier in the year. If you have any questions, talk to your teacher. Otherwise, have a great day.